The scientist 6 designed it to find out the maximum and minimum temperature in a day at a place. It consists of a narrow U tube whose one end connected to a cylindrical bulb and the other end is connected to a spherical bulb. The apparatus consists of mercury and alcohol. The arms of the U tube are calibrated with the required scale. Suppose the left arm is marked with the ascending values from top to bottom, then the right arm should be marked with the ascending values from bottom to top. See here the working of 6's thermometer.
It is a 6's thermometer which measures the maximum and minimum temperatures of a day. During the increase in temperature, the mercury level rises into this narrow tube, so the balls they raise up. During the decrease in temperature, mercury level falls down and rises into this tube. So these two balls raise up. So this side you can measure the minimum temperature and that side you can measure the maximum temperature.
The lower ends of the two indices give the maximum and minimum temperatures of a day respectively. The melting and boiling points of some substances determined at normal atmospheric pressure are given in the table. Substance: water, melting point 0 degrees Celsius, boiling point 100 degrees Celsius. Wax, melting point 60 degrees Celsius, no boiling point. Substance mercury, melting point minus 39 degrees Celsius, boiling point 357 degrees Celsius.
Ether,
Melting point minus 120 degrees Celsius, boiling point 35 degrees Celsius. Glass, 1127 degrees Celsius melting point, no boiling point. Iron, melting point 1537 degrees Celsius, no boiling point. Remember the following points. 1. When a substance is heated, its mass does not change, but its volume increases in general. 2. Few substances contract on heating. Example, wax, rubber, soft iron, etc. That is, their volume decrease on heating. Next point, melting point of a substance decreases if the external pressure is increased. Boiling point of a substance increases if the external pressure is increased. On the mountains, melting point of a substance is higher and boiling point of the substance is lower. 1 degree Celsius equals to 33.8 degrees Fahrenheit equals to 274 Kelvin. That is, 1 degree Celsius is less than 1 degrees Fahrenheit is less than 1 Kelvin. When the heat energy flows into our body, we feel hot. Conversely, if the heat energy flows out of our body, we feel cold. Heat is an invisible energy which causes in us the sensation of hotness or coldness. Heat energy flows from hot body to cold body till both the bodies attain the same temperature, which is named as equilibrium temperature.
This is fire and that is the ice cube placed over a stand. Ice cube is at low temperature and fire is at high temperature. That's why heat always flows from the body at high temperature to a body at low temperature. That's why you see here the ice is melting.
In the equilibrium state, the amount of heat energy lost by the hot body equals to the amount of heat energy gained by the cold body. The rate at which the heat energy flows from hot body to a cold body depends upon the difference in temperature of both the bodies. In winter, a cup of coffee cools quickly. That is, more amount of heat energy is lost by the coffee in 1 second. In summer, the cup of coffee cools slowly. That is, less amount of heat energy is lost by the coffee in 1 second. The amount of heat energy required to raise the temperature if 1 gram of water through 1 degree Celsius is called calorie. It is the CGS unit of heat. The amount of heat energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius is called standard calorie. 1 kilocalorie equals to 1000 calories. 1 calorie equals to 4.2 joules and 1 kilocalorie equals to 4200 joules. It is the amount of heat energy required to raise the temperature of a given mass of a substance through 1 degree Celsius. Heat capacity equals to HR by theta R, where HR is the heat energy given to the substance and theta R is the raise in temperature. Its units are calorie per degree Celsius in CGS system and joules per Kelvin in SI. 1 calorie per degree Celsius equals to 4.2 joules per Kelvin. It depends on the mass of the substance and nature of the substance. It is the amount of heat energy required to raise the temperature of 1 gram of a substance through 1 degree Celsius. Specific heat of a substance of mass m is C or S equals to 1 by m into HR by theta R. That implies HR equals to mc theta R. It depends on the nature of the substance. Its units are calorie per gram per Celsius degrees in CGS system and joules per kg per Kelvin in SI system. 1 calorie per gram per Celsius equals to 4200 joules per kg per Kelvin. In equilibrium state, heat lost HF equals to mc theta F, where theta F is the fall in temperature, and heat gained HR equals to mc theta R. Therefore, HF equals to HR. Remember the following points. In liquids, water has highest specific heat, that is, specific heat of water is 4200 joules per kg per Kelvin. The materials which allow the heat energy to flow through them are called good conductors of heat. Most of the metals are good conductors of heat. For them, specific heat is lower. The materials which don't allow the heat energy to flow through them are insulators or bad conductors of heat. Example, wood, cork, rubber, mica, etc. For them, specific heat is higher.